Hello and welcome back, statistics students. We are still inside of chapter 9 and we're still on the baseball example. I've already done 6 examples over this, so please, if this is your first time on this video, you can go back and look at that if you want to see the data. But I'm on to number 7 here, where it says use the least squared regression line for the re-expressed data. Remember that we did this re-expressed logarithm right here a while back, about 4 or 5 videos ago. And I want to use that to predict the average salary in the year that was missing. Okay, it's important for you to remember that there was a year that was missing here. Okay, if I go back to the original data here, this 1968, it's missing, right? That thing's missing. So because it's missing, we are going to figure that one out, and it says for the next year, which I'm doing this video right now, it's 2019, so the next year technically would be 2020. Okay, and of course then it says how confident are you in these predictions. We'll hold off on that section until we actually have them. So the first one I think I'll do here in red, and we'll do 1968. Well, I want to take 1968 and I will plug it in here for the year, but remember the year up here is years after 1900. So there are 68 years there, so that means that I have log of my salary, this prediction, is equal to negative 3.002 plus 0.064 times 68. You can't put 1968 because we made the model originally for years after 1900, which is 68 years. Okay. Now just take out your calculator and go ahead and plug those in. I got 1.35 after I plugged it in, and that of course is equal to the log of the salary. That's prediction. Now be careful here. We're not done. I want to know how much, like it says the average salary for that year. Right now all I have is the log of that salary. So I have to undo the log here. This is a classic algebra 2 problem where you should remember that because I didn't write any base here, this is a base 10. So to get rid of that, I put 10, like I power it, or I base it 10, which would cancel that out, right? Of course here, then I have to like base 10 over here, which, yes, this cancels out and I get the salary, the predicted salary, equal to 10 to the 1.35 power. Again, just a simple calculator problem there, and I get this to end up being the salary is equal, the predicted salary now, of course this is for 1968, is equal to 22.387. Does that mean that that is $22 and what, 39 cents? Well, of course not. Remember that this is in thousands of dollars. So this is in thousands, right? Which means since it's in thousands of dollars, I moved this decimal place 3 times, and my predicted salary for in 1968, the average salary, okay, predicted average salary, would be $22,387. Okay. And that's just doing the first one, right? This 1968 one. Now we need to do the exact same thing, but for 2020. Okay. Now would be a great time to pause the video and try that one out on your own. Okay, now that you've tried it out on your own, I'll write mine in there. I'm going to go a little bit faster here, though, so I'm going to abbreviate some things like log sal here equals negative 3.002 plus 0.064. Now, 2020, right, would be 120 years since 1900. which when I multiply that out, I get 4.678 here. Okay, now we've only been using 3 decimals the whole time, so most likely if I was in science class, like I would need to round that. We'll keep that there. It will throw us off slightly, but we won't throw a huge fuss over it. Then we have to power that. We know we have to power this to the 10, so 10 to the power of 4.678, and I get 4,764,3.0987, right? Now, that looks like 47,000, which really, I mean, that makes kind of sense, like $47,000, okay. But remember, this is in 2020, and this is still in thousands of dollars, right? So since this is in thousands of dollars, we have to move the decimal place. So we say in 2020, the predicted average salary is, well, move this 3 times, right? Which maybe I'll round this to a 9 then. So that's 4,764,3,098. Now let's put the commas in there. That is $47 million is the average now. Okay, that's the predicted average in 2020. I have done 1968 and next year, 2020, right? I did both those. Now it's time to answer this question. Let me get a different color here. How confident are you in these predictions? And it's a simple but loaded question here, okay? When I look at 1968, this one here, right, and I think back to the original data, 1968 is in our original data. It is in between data values, right? It's what we know as an interpolation. That's known as an interpolation. But when I think about 2020, the biggest data value I have is 2001. That means 2020 is like way down here, okay? This is not inside the current data that I have. This is known as an extrapolation. Okay, we have an extrapolation here, and we have an interpolation up top. We trust when we do stuff inside. We do not trust when we extrapolate. So, I feel confident in my prediction for 1968, but not for 2020, because 2020 is an extrapolation. Yeah, I know I kind of wrote that all over the place, but because of the different colors, you should easily be able to see that. You could probably fit it in down here. Okay, you have a little bit more space. And this is one of the most important problems to really nail on this example. Okay, so please go back and listen to this one again if you're confused on how I got those numbers. But my final solution is this part that I'm boxing here in purple, both of these boxes, and the written part out in purple.